are starting into 4.3.1 today. I don't really think I will get this all done today, so I will probably run into tomorrow to get this all done. But 4.3 starts our look at the unit circle. When I say the unit circle, I'm talking about the circle on the wall over there. I'm talking about the circle that is on the previous page of your notes. Okay? So that is referring to the unit circle. And I'm not sure when I want to hand it out, but I have another unit circle I'll hand out to you also that we can use as references here. Okay, so with that in mind, guys, okay, lesson 4.3 is really just how do we work with the unit circle, how does it all go together, learning all the pieces of it. Okay, so a little bit of vocabulary here. When we talk about an angle is going to have an initial side, which is your beginning side. Okay? An initial side or beginning side is always going to begin at 0. Okay? 0 is the same as being at 3 o'clock. Okay? On the unit circle on the wall, you will see it as, it says 2 pi, but I've also written that in that it's 0. It's our beginning point. It's our ending point. Okay? On the unit circle in your notes, it says 0, 2 pi, 0, 360. So just understanding that that is our beginning and ending point. Okay? Or once you go all the way around the circle, that's an ending point. So 0 being our initial side, terminal side being your ending side. When we're measuring with the unit circle, a traditional angle is going to go counterclockwise. And so that's why when I said a traditional angle, meaning a positive angle. So the idea that this begins at 0, that's your initial side, and then we meant to measure positively, you're measuring counterclockwise from 3 o'clock. Okay? And if you look at your unit circle, that's how it counts, isn't it? Okay, you can see, I'm trying to think what all's on that unit circle there, but you can see how it counts. They have 30, 45, and 60 in that first quadrant. And then 90 is straight up. And then 120, 135, 150 continue around in that second quadrant. Okay, so another way to think about it, where is quadrant 1? Quadrant 1 is right here, yes?
Yes.
And if this is quadrant 1, you're starting and counting in quadrant 1, then quadrant 2, then quadrant 3, then quadrant 4. So you're counting with the quadrants just as well, if that makes sense. Okay. Now, positive angles go increasing numbers, right? Go positively. Negative angles, they also start at 0. Okay, everything starts at 0. But negative angles are going to go counterclockwise. Okay, so when we go negative, if you're given a negative angle, that means instead of going up and around, you're going to go down and around. And so that is clockwise there. And so that means like if straight up is positive 90, then this straight down is a negative 90. Okay, so you'll quickly learn on the unit circle, all these angles have multiple different names. Not just one name, not just two names, but there's multiple different names here. Okay, now more vocabulary. Coterminal angles. Coterminal angles are those that start at the same initial side and end on the same terminal side. They simply swing around the center more than once. Okay, so this is the idea that every angle has multiple names. Okay, there's a name for if you go positive and just go once around the circle. There's a name if you go negative to get to it. There's a name if you keep going a couple of times and then stop at it. And that's what we're going to look at. Okay, so an example of coterminal angles. We'll start with degrees, because degrees is what we've been brought up with, right? So degrees are going to be a little bit easier for us to understand. But the claim here is that 90 degrees, 450 degrees, and negative 270 degrees all name the same angle. Okay? So let's look at that and talk about that. 90 degrees. Where's 90 degrees? Yeah. Okay, you start at 0, yes. And So the idea here is if you start at 0 and you go up here, this is 90 degrees, yes?
Yes.
Logical there. Now, we can also claim that besides this being 90 degrees, it is 450 degrees.
Oh.
So, this unit circle is not just once around and done. You can go around this infinitely many times. So, okay, if we start here at 0, right? And then if we keep, so if we go here, this is 90, yes?
Yes.
And just pretend the rest of the circle there. Where am I at right here?
180.
180. Where am I at down here? 270.
360.
Add another 90. We're at 360. Where are we at up here?
450.
450. So is this indeed also 450?
Yes.
Okay, does that make sense what we're looking at there?
That's a lot of numbers.
Okay, well, I'm trying to get you to visualize that, okay, if we go around here and we stop up there, that's the idea of 450. That's what I was trying to get you to connect. Okay? And then negative 270. Are you a believer yet?
Yes.
So what's negative tell me to do? We start here and we go down. So if I start here, let's see. I'm going to start in here. Where am I at if I just go to the straight down angle? Negative 90. If we keep going, then we're now at negative 180, and now we're at negative 270. That's 3 different names for the same angle. Are those the only names for that angle? No. Okay, it's not the only name for the same angle there. And notice, mathematically, how do you get from 90 to 450? Don't think multiply. And adding.
360.
You add 360.
That's good.
Because if you're at 90 and you go around the circle again, you add 360, yes?
Mhm.
How do you get from 90 to 270 mathematically?
You subtract 360.
Subtract 360. Okay? So if we wanted to, we could subtract 360 again and have another name for this angle. Or we could add 360 to 450 and have another name for this angle.
What you said?
Okay? So infinitely many names for one little angle. Okay? Now, the tough one. We also have to work on radians. Okay? And I know at the beginning, it is very tempting to just convert everything to degrees. But you don't want to fall into that trap. We've got to learn to work with radians. Not saying that there's not times we're not going to convert back and forth, and I'm going to use those connections, but you've got to learn to work with radians. I know looking at the circle, it's really easy to be like, oh yeah, I can pinpoint 90, 180, 270, 360, but we need to be able to do the same type thing with radians. Okay? So, the claim here is that pi, 3 pi, and negative 99 pi are all the same angle. So, let's start with the basics. Pi.
180.
Okay? Pi is equivalent to 180, yes? So what's an angle that is pi look like? It's a straight line, yes? Because we know 180 is pi, or 180 is a straight line. So when we talk pi, okay, again, keep in mind zero's over here, yes?
Yes.
And if we go over to here, we're at pi. That's our base angle, so to speak. Now, the claim is that 3 pi is the same. So, okay, if we start here at 0, at this point I'm at 1 pi, right? What am I at over here?
2 pi.
2 pi. So once around the circle is 2 pi. What if I go another half circle here?
Oh my goodness, that's 3 pi.
I'm at 3 pi. Okay? Because every half of a circle is pi. And I know that's confusing at the beginning. You'll catch on. Now, if we kept going positively, trying to make a connection here, what would be the next name for 3 pi?
4 pi.
It would be every odd number.
Oh.
5 pi? Is Emma's comment making sense here?
Yes.
That because right here, if we're here at 3, 4 pi would just put us back over here. So if you go all the way around again, basically if you take 3 pi and add 2 pi, you're going to be at 5 pi. What's the next number after 5 pi? 7 pi.
After that's 9.
Okay.
Then 11.
Okay, now, so you're noticing a connection here, yes? Now, negative 99 pi.
Oh.
I'm not drawing that one out, needless to say.
Oh, I was hoping.
Okay, that would be a little crazy. You're already coming about lots of dots. Okay, but
we could do straight like.
let's make sure it makes sense. Negative 99 pi. So where do we go with negative? Negative, we're going to go down and around, yes? So like here, going this way, right now we are at negative pi, correct?
Yes.
If you go around a whole time again, you're now going to be at
Negative 3.
-3,
And
-5, -7. Is that enough to make you a believer that it's negative 99 pi as well?
Yes.
Okay, all of your odd numbers are going to match up over here. So while we're here, what's that mean about 0? 0 is also what? The even numbers, because it's going to be 2 pi, right? What's it going to be after 2 pi? 4 pi, 6 pi. You're catching on here? Okay. And again, it's about understanding the basics of the unit circle. You will notice down here, these angles simply differ by an integer multiple of either 360 or 360 degrees or 2 pi radians. And that's because the circle measures either 360 degrees or 2 pi radians. We've already made that connection, right?
Yeah.
Okay, so when you're trying to find those coterminal angles, differences of 360 if we're talking degrees, or differences of 2 pi if we're talking radians. Okay, so go down and look at example 1,
Example 1.
which is right below it. It's on a different screen for me. You have a section like this in homework, if I recall. Find a positive and a negative angle that are coterminal with the given angle. So, thoughts? If our given angle is 30 degrees in example A, I need a positive and a negative version that are coterminal with 30 degrees. 390. Agree, disagree?
I agree with that, Mario.
How do we get 390?
I have no idea. We added 360 degrees.
Okay,
You just add.
so a coterminal angle is an angle that's the same name. So if it's the same name for it, you're just going 360 degrees around again. In other words, you're going another loop around the circle. And so if you're already at 30, and you go a loop around the circle, you're adding 360 and putting us at 390. So what? Negative 330?
That's what I got.
Why negative 330?
You got to subtract 360.
So if you start at 30 degrees, but instead of going forward a whole circle, go backwards a whole circle, you're going to subtract 360. And 30 minus 360 is 330 degrees.
Negative 300.
Yep. Agreed. A minor detail makes a huge difference. Okay. Because here's what you've got to realize. Positive 330 degrees and negative 330 degrees are not the same angle. They're in different locations. Okay? Okay, are we okay with that?
Yeah.
And keep in mind, are these the only 2 correct answers? No. These are the obvious 2 correct answers. But you could add 360 again if you want. You could subtract 360 again.
Will we ever have to do that multiple times?
No, not usually. Usually it's a positive and negative, or, give 2, and so. Okay. B. The given angle is negative 150 degrees. I need a positive and negative coterminal angle.
210.
And how do we get 210?
150.
So negative 150 degrees plus 360 degrees, I'm being told is 210 degrees. Are you guys putting your degree bubbles on there?
Yes.
Silly little question, but if you don't put a degree bubble on there, I'm going to think it might think it's radians. So you want to be labeling with your degrees.
The next one should be -5 degrees.
We must agree. So this time you're doing negative 150 degrees minus 360. Negative 510 is the agreement. Okay.
Yeah.
Switch
Okay.
degrees.
Nope.
Oh.
Nope. We're not switching
Obviously
degrees.
not.
We have to work in radians.
About working
Switch
in,
degrees.
we
No.
talked about working in radians. Obviously, we're not going to switch to degrees.
Yeah, maybe if you pay
Okay, guys.
attention.
Focus here.
Drift around.
Now, and here's the deal, guys. I'm not saying that you're not going to get a right answer if you switch degrees. You just still have to switch back to radians. But it is hugely important to learn how to work with radians. Not all radians are going to easily switch to degrees. I get it. 2 pi over 3 would be an easy angle to work with in degrees. But we have to learn how to work in radians too. So it's very rare that you'll see me switch to degrees on something they give us radians. I might refer to it, like, okay, it is equivalent to whatever this is, but we're going to work with this. So how do we change this problem up then?
You two the ones love radians so much.
Okay, you're going to add 2 pi. Everyone should know that.
What'd you say?
360 is the same as 2 pi, yes? So 360 is the same as 2 pi. We've been adding and subtracting 360 over here. We're going to add and subtract 360, but it's going to be 2 pi. So now, we're going to do 2 pi over 3 plus 2 pi. Okay? One of the difficult parts about working with radians is we have to talk fractions. Okay? We're not going degrees. We're going to talk fractions. So in order to add 2 pi over 3 and 2 pi, we need a common denominator.
Oh my gosh.
So,
We're just in sync.
what is a common denominator here?
3. Wait.
If 2 pi over 3 is already 3, it has a denominator of 3, it's the only denominator there, so it's the common denominator. So what is 2 pi in terms of thirds?
6 pi.
It is 6 pi over 3, right? Multiply by 3 over 3. So then what's 2 pi over 3 plus 6 pi over 3?
8 over
Alright.
3
8 pi over 3.
Yeah, you know what I meant.
I know what you mean.
I wrote the right thing down.
Now, and here's what I am going to say, guys, because that brings up a great point. I wrote mine as 8 pi over 3. The other option would be to write it as 8/3 pi. That would be equivalent. Now, you'll usually see me write 8 pi over 3, but we have to pick on Connor a moment.
It's so much
You write 8 over 3 pi,
wrong.
and that's wrong.
I wrote down
Okay,
the right
and I know, but it was just, it's a good time to talk about it.
Yeah.
Sure.
Okay.
Sure it is.
So, 8 pi over 3 with the pi on top, or with the pi next to the fraction. But you can't put it in the denominator, okay?
I can see where that could be
I don't know why
a
I
simple
flinched,
mistake.
but I really thought he was kidding.
Okay, continuing. Are we done with this problem?
Yes.
No.
No.
You have to
I'm not.
subtract 2 pi.
Okay, we need a negative version. So just like you could subtract 360 degrees, we can subtract 2 pi, which means I'm going to do 2 pi over 3 minus
6 pi.
6 pi over 3,
Oh, yeah, I forgot that.
which is
Negative 4 pi.
negative 4 pi over 3.
See, I was gonna say it, and then
Not
I
negative
sat
4
there
over
and I
3
thought,
pi.
Okay, now, please focus. Those are examples of coterminal angles. Understand that, again, one angle is not just one angle. It has lots of different names. 8 pi over 3, negative 4 pi over 3, 2 pi over 3, that's all the same angle. Okay? That's all the same angle that you look, if you look, is in quadrant 2. It's just different names for it. Okay? Moving on to the bottom there. And another vocabulary word, and this is a hugely important vocabulary word as we continue on in pre-calc, and that's reference angle. Okay? we talk about a reference angle is the angle that a given angle makes with the x-axis. When we're giving these other angles, we're starting at 0 and we're just measuring around the circles we get to. Okay, a reference angle is, okay, how far is that angle from the x-axis being my horizontal axis. And when you give this reference angle, it's an angle it's a positive value, and it's always less than 90. So you're going to the closest point from the x-axis. Okay, so reference angle, it makes the angle with the x-axis. It's always a positive value, and it's always less than 90 degrees because you're looking at how close is something to the x-axis. Is it closer over here? Let's see, 0 would be over here for you guys, wouldn't it? Is it closer over here at 0? Is it closer to 180? Is it closer to 360 down here? What is it closest to? Okay, so reference angle is always from 0 to 180, or excuse me, 0 to 90, and always positive. When we talk about getting that reference angle, you're usually either subtracting to or from 180 or 360 because those are the pieces, right? Over here, it's 0 if you go up. Over here, you're close to 180 above or below. Over here, down in quadrant 4, you're going to be closest to 360. So it's how far are they from the x-axis. Okay? Some of these are going to be easier to figure out than others. Okay? So, oh, and keep in mind, when we say always less than 90, that means it's somewhere between 0 and 90 degrees in degrees. If you're given a radian one, yes, we're going to work in radians. So in terms of radians, it's always between 0 and, what is 90 degrees in radians?
Pi over 2.
Pi over 2.
Oh, I'm so close.
Because pi is
180.
180. So half of 180 is 90, half of pi is pi over 2. Okay? So, we need a reference angle for 256 degrees. First thing you've got to know is where is 256 degrees? Like that.
No.
Did you say let me think? So 180 is like
It's a lot closer.
Yeah, it's close to me.
Because
Now.
it'd be like 76 degrees with it'd be a lot more than that.
Now, okay. Here's my 0, yes?
Yes. You're not talking about it, so.
Okay. Let's figure out where 256 is. If we're measuring, right? Up here would be 90. Down here would be 180. What quadrant is 256 going to fall in? It's going to fall in the third quadrant, yes? It's going to fall somewhere. This is not precise, just deal with it, okay? It's going to fall somewhere like that. Are we okay with that is where 256 degrees is?
Yes.
Yep.
Now, I want you to be able to come up with that on your own. However, does the unit circle reinforce that?
Yeah.
Yes, because you'll see things like 210, 225, and 240 labeled, right? I probably should have gone a little bit farther now that I think about it, but
it's a
it's all right. I got it in the right quadrant, which more than anything, that's what matters. Now, I want to know this angle here. What angle does it make with the x-axis? The x-axis being a
180.
horizontal axis, yes? So here's my x-axis. Where is that angle closest to the x-axis? At 0, at 360, at 180?
180.
It's closest at 180. So when we talk about the reference angle, I want to know that distance right there. I want to know the distance between that 256 and that 180.
Should be 76.
Logical math says in order to find the distance from the 256 to the 180, we're going to subtract them. And 256 minus 180 degrees is 76 degrees?
Yep.
Okay. Does that make sense, sir?
Yep.
Okay? Because so if we talk about 256 degrees, when we go to, okay, what's the sine of an angle like this? What's the cosine of an angle like this? What's the tangent of an angle like this? We're going to use reference angles, and that 30, 45, 60 chart that you are supposed to be learning, that's going to be hugely important. Okay? Okay. 8 pi over 7. Now, this one's a little more difficult for a couple different reasons. One, you're not going to find sevenths on your unit circle. So we have to think a little bit more. Okay? Here's 0. Now, I always think in terms of, I start off by referencing how big is my angle in reference to 1 pi. In other words, 8 pi over 7. What do you know about 8 sevenths? It is slightly larger than,
7.
it's slightly larger than 1 pi, yes?
Yes.
In other words, it's because it's slightly larger than 7 sevenths, which is 1. Where would 7 sevenths pi be?
Here.
Or 1.
7 sevenths pi is the same as 1 pi. So logically speaking, where is 8 sevenths pi going to be? Which quadrant?
2. 3.
3.
It'd be in quadrant 3.
Quadrant
Oh, wait,
3
yeah.
because you have to go a little bit past
Because it goes like that.
1 pi.
Yeah.
Logical?
Yes, I got
I'm
it.
trying to make sure everything's
I got it
logical
now.
here. Okay, so the idea here is if we start here at 0, at this point I'm at pi. If I go a little bit past it, and I don't know that that's, probably went too much past it, but I'm at 8 pi over 7 because I have to go a little bit past 1 pi. So find other angles that you can reference. Now, with this in mind, what angle are we closest to on the x-axis?
180.
180, but I don't want you to call it 180. Pi. See, I'm not throwing away the degrees totally, but I need you to think pi, radians for me. So, how do I find the difference of how far apart 8 pi over 7 and pi are?
8 pi over 7 minus 7 pi over 7 pi over 7.
Okay, 8 pi over 7 minus 7 pi over 7. And we're saying 7 pi over 7 because that's equivalent to pi, right? And what is that when we subtract?
5 over 7.
Pi over 7.
Not 7.
Okay, we will have to start by talking about C at the beginning of class tomorrow. Or maybe I'll have you guys think about C at the beginning of class tomorrow.
Okay.
Okay? And then we will finish the back page of the notes.
So homework's not due tomorrow?
Homework will not be due tomorrow. What's today? Tuesday. Tomorrow's Wednesday, so that makes it what, due Thursday?
Sounds great.
Sounds right.
I'm trying to figure out my days of the week here.
I guess.